Okay, we're going to continue talking about Excel today. And so for now, please switch off your screens just to remove any distraction. And then I'll have you switch them back on a little bit later because we're going to work through a number of activities together. I also do have another homework assignment for you. This is homework 4. It's due on Thursday the 21st. This is also posted on EDU Online, and this is another assignment you're going to submit entirely on EDU Online, because what you're going to be uploading is a couple of spreadsheets. I want to show you one of the starting files that you're going to use for the assignment. Okay, so on the assignment, this is going to be another one that you submit online. And the starting file, we'll go to MU Online and take a quick look at that. All right, so two things. The first one is that today we're going to be doing an in-class activity together, and when you're done, you need to upload your Excel file for attendance to this thing that says 2.9. We've done that before, but it's just on the main page for the course. The homework assignment that you need to upload a week from today, that goes into the homework assignments folder, and it's just right here, homework 4. So you'll upload it the same way you have before, where you browse to any files you want to attach. But another thing is that there's a starting file for that assignment. So you click on homework 4 starting file, download that, and you're supposed to do your work for the assignment for problem 1 and problem 2. You're supposed to do your work in that provided template, just so that everybody has the same starting data and is submitting it in the same format. I think that'll make things a little bit easier for you. So again, to access that, you start in the course homepage and then go to the homework assignments folder. Yes?
It said the homework's due a week from today, but it says it's the 21st. A week from today is the 16th.
21st, Thursday. And today is a Thursday, so the 21st would be a Tuesday, right? What does the handout say? Does it say when it's due, 21st? All right, so let me change that to say, thank you for noticing. Tuesday. Good catch. Are there other questions? All right, so that's the next homework assignment. In fact, you can get a good start on that homework assignment just after today's class if you're the kind that likes to get things over with and just touch it once so you can be done with it. Today we're going to start talking about order of operations, which has to do with how Excel does calculations and how you put complicated equations into cells. We're also going to do a little bit of work with graphing and curve fitting. And so this is a pretty useful lecture when it comes to all of the labs you're going to have later on in your engineering career, where inevitably you're going to be gathering physical data, and then you have to graph that data and create reports where the charts are in the reports. And so we're going to look at some of the way to make like presentation quality graphics today. Okay, now remember that when you're doing a formula in Excel, the way that you tell it you're about to do an equation is with the equal sign. And the equal sign is kind of the key to doing anything other than just entering direct data. So you couldn't type in 3 plus 3. It wouldn't know what to do with that. But if you typed in equals 3 plus 3, it will perform the calculation. But there are certain calculations it'll do first. There's like a priority list of the order that calculations are done. It doesn't just do them from left to right. That's how we type it in. You know, we have to type things in a linear way. But this is an example of how Excel would calculate things a little bit differently than you might initially first expect. Let me see if I can make that a little bit bigger. So let's see. No. Oh, let's see. All right. So this formula. Try doing it on a scratch piece of paper. Like, what do you think the answer to this is? And then we're going to type it into Excel and see if you and Excel agree on the answer to this example. The stakes are low here. You're not going to fail the course if you get the wrong answer here. It's just for illustration to show you why we have to study this order of operations stuff. Okay, so maybe by now you've already taken a guess at it. Just before we put it into Excel to see what it gives us, what are the point of ambiguities? Like, is there anything about this that makes it especially tricky or uncertain? 2 to the power of 5/4. And why do you feel like this part of it is tricky? Okay, so is it 2 to the power of 5/4 or is it 2 to the power of 5 divided by 4? Let's see how Excel interprets that. And then after we put it in, we're going to learn a little bit about the rules, the order that it performs its operations. All right. Let me zoom in to try and make it nice and clear so everybody can see. Equals 1 plus 2 times minus 2 to the power of 5 divided by 4 times 3. All right. Negative 47. Anybody else get that? Negative 47. What was if you didn't get that, what did you get? What did you get?
Negative 127 over 12.
Negative 127 divided by 12. Okay. So the point of ambiguity we were talking about, like whether it was going to do this exponent to the 5th power to the 5/4 power. Let's put in some parentheses there because parentheses would force that together as a fraction. So if I put in those parentheses here, so now it's definitely to the power of 5/4. Oh, what did I do here? I didn't like that one bit. Frankly, I'm surprised. I don't know that there's anything wrong with that formula.
You might still think that.
All right. So let's talk about the order of operations and see if we can figure out what the deal is with the way that Excel does its calculations. There's a way to remember it called PEMDAS, and it will do things in parentheses first, followed by exponents. It'll execute an exponent before it executes the multiplication and division. And so back to this example, what it was doing is it was executing 2 to the 5th power before it was doing the division. So it was seeing that as 2 to the 5th divided by 4, because the order of operations is that parentheses come first, then exponents, then multiplication, division, and then addition, subtraction. And so then I guess another point of ambiguity back to this example is what is it going to do first? Is it going to do 1 plus 2 and then multiply that times all the rest? Or is it going to do the multiplies first and then add last? And the answer is it adds last. The order of operations, the sequence, is that it will look around, first of all, parentheses, because parentheses is a way to force it to do things in an order that you prefer, rather than what its natural order is. But in the absence of parentheses, it'll do first the exponents, then multiplication, division, and finally addition, subtraction. Here are some other operators. There's the negative sign. If you put in a percentage, then it automatically knows to divide by 100. The multiply is shift 8 to get that star. Divide is just next to the shift key. Add, subtract. And we'll get to a little bit later on in the course. That's a way of saying that two things have to be together. And then there's also comparisons in if-then statements. If you want to have a conditional thing like if something is true, then do something else, it'll do that last. All right, so let's take another stab at this. Now, do this with your calculator, just on paper. Find the solution to this, and then we'll talk through how you'd apply the order of operations. So don't just do it, don't just find the answer, but try and write this on paper in a way that would illustrate the way that Excel is going to see it. And so it's going to do P, E, M, D, A, S. So parentheses, exponents, multiplication, division, add, subtract. So for this one, just write a step-by-step of how Excel would solve this problem. And parentheses doesn't mean that it does it first. What it means is it takes priority. The parentheses will force things to happen in a way that you prefer that it otherwise wouldn't do. And so here, it's going to be the multiplication and the division that's first, because these parentheses are going to change the order. I think you'll see what I mean in just a minute, but find the answer to this, and then we'll talk more about the ordering. All right, starting with parentheses, what we have to do is look for the innermost parentheses and do that first. And so there are two parentheses that are the innermost parentheses. There's the 1 plus 0.04, and there's the 1 plus 0.06. I'm sorry, 0.6. Also, there's another parentheses. These brackets act as a parentheses, but what that means is before we do the 23 times everything else in the brackets, we have to do all of the other operations inside of there before we get to the multiplication. Because the fact that this entire block of calculations is itself in a parentheses mean all of them have to be finished before we do that multiplication that's outside of the parentheses. And so the first place that we start with the parentheses is is writing it as 1 plus 0.4, so that becomes 1.4. Even though addition normally would be low on our priority list, the fact that it's inside the parentheses means that we do it first. So 1.4, and then it's going to be to the third power, 5 times that, divided by 1.6 to the power of 2 minus 1, and then a big parentheses, which is the brackets. All right, so the first operation of parentheses was just meaning that we do the addition as our first step because it's inside the parentheses. So next, exponents. Okay, so what that exponents next means is that, but we don't do 5 times. We would do the 1.4 to the third power and 1.6 to the second power. And so for the exponents operation, that means that we're going to be left with 5 times 2.744, which is 1.4 cubed, and then 2.56 minus 1, and then still multiplied by 23. Okay, so we executed the exponent calculations. Next is the multiplication and then the divisions. All right. So the multiplication is going to be the 5 times 2.774. That gives us 13.72. Now this is a little bit of a tricky part here. We know from looking at it that the 2.56 minus 1 has to be combined together. We can't just divide 13.72 by 2.56. And so the fact that this is down on its own line means that we're going to do that subtraction operation. And what we're left with is 1.56 when we subtract the 1. All right, and then we do the overall division, the 13.72 divided by 1.56. 56, so that gives 8.795, and then finally multiply that by 23. So how many people got 202.282, and the numbers continue. Great. Good. Now, see if you can type that into Excel. I'm not going to show you first. I'll have you take a first stab at it, and then I'll work through it. And if you didn't get it right the first time, you can follow my step-by-step to see if you get the same thing. So you know what the answer should be. Make Excel give you the same answer. Okay. One thing to keep in mind is there's more than one correct way to type it in and get the right answer. Because you can put in lots of extra parentheses that it'll honor all the parentheses you put in, but you can put in more than are required and still get the right answer. All right, so we start off with these parentheses because we know that in the end, maybe we're going to have to multiply by 23. So 5 times 1 plus 0.4 to the power of 3. All of that divided by 1 plus 0.6 squared. Let's see. It puts in colors for the parentheses to try and help you keep track of them as you're closing them. See how it was just briefly bolded there as I closed that one?
You don't need the parentheses.
Yeah, I know.
on the third.
Yeah. We're going to show how you can take parentheses out and then get the same answer. All right, so let's go through and make sure that I got that in right. 5 times 1.04 to the third power divided by 1.06 squared minus 1 times 23. All right, fingers crossed, right? Problem. Minus 1. All right, let's put this in. Force it to do that squared and then minus 1. Which means I need to put another one in over here.
You need 2 on the right.
All right. Okay, so there's excess parentheses in there right now. For example, we could remove this set, and it's still going to give me the same answer. All right, we could remove, I think we can remove this set. Minus 1. No, that one's got to be there. These ones ought to be able to go. Yeah, all right. So the point is there's more than one way to type it in, but it's always going to do the parentheses first, then the exponents, multiplication, division, add, subtract. So if you look at the homework that I've given you, you're going to get lots of practice typing these into Excel. You've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 problems that you need to do in Excel. And that should give you some good practice on how to type formulas in. All right, well, let's talk about data now. Like I was referring to just a minute ago, you're going to take a lot of lab classes in engineering, regardless of what discipline you're in, whether you're in civil, mechanical, or electrical. All of those different programs have a lot of labs where you have to take measurements into a lab book and then sometimes like try and perform an analysis. And when you just look at these numbers, the trends don't jump out at you in the same way that they do if you graph the data. So if we were to take this data and have a graphical representation, it shows that data set 1, there seems to be a trend, but it's not a very tight trend compared to data set 2, which we can see is following a very, very clear pattern, like a parabolic distribution. This is relatively linear, but then there seems to be an outlier. where if this was measured data from a lab, we'd maybe say, well, who took this lab measurement? You know, it was somebody who didn't know how to read the instrument maybe. So it's very obvious that graphing the data helps you to understand what the trends are, and you can interpret what's going on more easily. But graphs can be misleading. And here is a figure that came from the New York Times that was showing the progression of fuel economy in the United States, where back in 1978, the average auto got 18 miles per gallon. But then by 1985, the federal requirements were going to be that the average automobile should get 27.5 miles per gallon. Now, what's a little bit deceiving about this is it's trying to use perspective in kind of like a cutesy way. It's trying to make the perspective look like a road, and these lines are not scaled linearly. If you take that same data and actually do a linear scale of what it should look like, then this is the result. 18 miles per gallon in 1978, 27.5 in 1985. So this is the same underlying data, but you always have to be cautious with the way that data is being represented, because it might be to intentionally deceive you. All right, well, let's play around with Excel a little bit, graphing. And we've already done formulas and equations. So set up in a fresh workbook, just begin a new page here. And by the way, if you haven't already, save the file. And let's save it. I'm going to save it on my C drive. You should probably do it on your V drive. I'm just going to save this one and call it February 9th. All right, so that I can upload it at the end of class. All right, so what we want to do is create X and Y data. Here's X and here's Y. And the X should go in steps from -3, -2.5, and then all the way to +2.5 in increments of 1/2. So you know it'll automatically create the range in the increments that you set. And then for the Y, we're going to have it calculate this formula. So we want here in Y for it to be equals X squared minus 2 times X plus 4. All right. And then you can drag that down, and it'll always be looking at this updated X value. The equation? X squared minus 2x plus 4. Okay, does everybody have that data, that same data?
What's the formula again?
All right, the formula is, let me copy and paste it. So instead of typing in the number, you should refer to the cell location when you're doing the formula. So here in the formula, I'm doing equals, and I'm clicking on the cell location. Rather than typing in -3, I'm just clicking where the -3 is, to the power of 2, minus 2 times X plus 4. All right. Okay, let me remind you of the trick that you didn't have to type all of these numbers in. Excel is always looking for ways to save you time, and one of them is just if you type in the first two numbers, so -3, minus 2.5, even if all the rest of these are blank, it detects the trend of it's increasing by half for each one, and so as I drag it down, it'll automatically fill in the data for me. All right? And then the y is just based on the formula that I've typed in. All right, so now that we've got that, let's create a graph for this. If you go to the Insert tab, the type of graph that we're going to do is over here right under Charts, we're going to insert a scatter. And so if you click on the drop-down arrow, the type of scatter we'll put in for this one is scatter with smooth lines, and we're going to include the markers of the actual data. So click on that. Now sometimes Excel will try and guess what data you want to graph. So in some instances, what all you do is you tell it you're starting a graph and it'll automatically create one for you. But more often than not, it guesses wrong, at least in the times that I've used Excel. So you have to manually tell it what is the X values and what is the Y values you want to graph. And so if you click on this, what we're going to do is here in the Design tab, we're going to select Data. All right, so select Data, and I'm going to add a series. And for the X values for it to graph, you click here next to Select Range, and then I'm going to highlight this range of cells that the X is in, and do the same thing for the Y. Select the range of cells. I'll do this again in just a minute if you didn't follow. And then this is what it creates. All right, as its first guess of what we want it to look like. So starting from scratch, I'm going to delete that. I go to the Insert tab, and I'm going to choose the chart that's this drop down here, a scatter, and I want to do a scatter where it smooths the lines and still shows the actual markers for the data itself. All right, now I'm going to just move that so it's not covering the data. Make it a little bit smaller here. All right, and then select Data, add a series, and then you identify the X values for it to graph and the Y values for it to graph. All right. So this is what you should have when you do that. So we need to make this more pretty. It doesn't look good enough yet. I think that by default, probably the size that you've got looks a little bit different from mine. Let me make mine bigger again. Now it's a little bit more. Try changing the size. You'll notice that right now, see how it's going 5, 10, 15, 20? But if I make it bigger, now it's doing 2, 4, 6, 8. It kind of automatically on the fly changes the scaling there a little bit. Let's try moving this axis over to the left side as one thing. And so I can right click. If my cursor is hovering over the horizontal axis, see where it brings up that tag that says horizontal value axis? Right click on that, and then we want to format axis. And so what I can do is I can force it so that the vertical axis crosses at some certain value. And right now the vertical axis is crossing at 0. But I want to move those values over here to -4. So I'm going to change it to say axis value -4. And then it moves that over to the left side. That's a little bit of an improvement in terms of how it looks. So again, the way that I did that was I took my cursor and it's hovering over the chart, and I want to hover on the horizontal axis until it brings up that little tag, and then right click, format axis. It'll bring up this menu on the left, and I want the axis value not at 0, I want it at -4. Okay? As soon as I type that in, I can also change that. It's not called chart title. Maybe I want to change the title to say graph of example parabola. All right. And we can also put in axis labels. So if you click here, you see the little plus button. We want to add elements, and the elements that we can add are axis titles. And so now we've got one called axis title and another one called axis title. So we could just have this one, double click on the data, the text it already has, and we'll have it say X values. And then over here we'll change it just to say Y values. All these horizontal lines and vertical lines maybe don't add a lot of value for us. Maybe it's just making it visually more complicated. So we could delete those if we wanted. Just click on one of the horizontal lines and it'll select all of them. And you can press the delete button and they go away. The same thing is true of the vertical lines. Click on one of the vertical lines, press the delete button, and they go away, which is nice. Now we have a much cleaner look to it. And see how it's going 2, 4, 6, 8. If we didn't want it to do it like that, we can click the Y-axis and over here change the units. Like right now the major units are 2. We could change it to be major units of 5 instead. And now it's going to be counting 5, 10, 15, 20, and so on. Maybe we're interested in tick marks. And so click on the horizontal axis and then expand here where it says tick marks. And let's have it do tick marks that cross. And so it goes into the data and across the horizontal axis. And then for the vertical axis, maybe we want to have tick marks that are only on the inside for whatever reason. So we've got them now. Okay, let's make one other change to the graph and then we'll move on. What if we wanted these axis lines to be darker than they are right now? So you could click on the axis and then here where it looks like a paint can, let's change the line. It's a solid right now, but the color is gray. Let's change it to black. And then that makes that a much more dark and distinct color there. And so we'll do the same thing to the horizontal axis. We'll highlight the axis, click on the paint can, and then change the color to black. Okay, someone just asked about the minor tick marks. Let's try those out. Those are a little bit interesting. Click on the vertical axis here and go back to, let's see, where were that? Oh, the text options? No. Chart options. Right-click, format axis. All right. Right-click, format axis, and go to the tick marks and then the minor type. Make the minor ones outside. And then you'll see what it means by minor is it's between where it's actually labeled with the number values. And so in this case, it looks like the minors are increments of 1. So 1, 2, 3, 4. The numbers aren't shown, but the tick mark is there. And then 5 is where it's crossing the axis. So that's the difference between the major and the minor. Okay, well, another really important thing that Excel can do is called curve fitting. And that's where you can have it identify an equation that best describes the data that you've got. Sometimes it'll do linear regression, but there are other functions as well that it will curve fit for. And one of the applications for Excel is in hydraulic analysis, where you want to have data that describes the flow capacity of a channel, like right here is a canal that's carrying water. And the general trend is that when the water is deeper, like measured from the surface down to the bottom of the channel. When it's deeper, then it carries a greater flow rate. And there are other factors as well, like the shape of the channel, how rough the material is that the water is in contact with, whether there are rocks or other obstructions in the way. But there is definitely a trend there that relates the height of the water to the flow rate. And here, this diagram is just showing, if the depth of the water is relatively low, there's a smaller cross-sectional area compared to where the water is deeper. So let's say that we want to find a curve that represents this data. So create a new tab in the worksheet that you're working on, a new page, and type in this data where you've got height for one column and flow for the other. Let me paste the data so that it's easier for you to see and make it big. Now this isn't like evenly numbered, so you can't just sort of type in the first two numbers and have it automatically know what the rest are going to be. This one, because it's random environmental data, you have to actually type it in and not use Excel's sort of auto counting feature. Okay, when you've got this data, create a chart. But the type of chart that you should create in this case, insert, chart, but just the data points themselves, just a scatter without connecting the dots. So create a scatter plot without connecting the dots. And let's add axis titles to it as well, if you haven't already. On the horizontal axis, we've got the height, the water depth, I guess. So we'll call it, I'll change this. To be consistent, I'll call it height. And I personally don't think that these automatic lines that it creates are very useful, the grid lines, and so I'm going to delete the grid lines. You can leave them, it's up to you. What we're going to do is see if Excel can do something related to curve fitting to give us an equation that describes this data. And so the way that you do that, I'll pause for a moment until everybody has the data graph. Okay, so follow along as I do the following. Right-click on one of the data points, and it brings up this menu. What we want to do is add a trend line. And we're going to start with a linear trend line. And if you scroll down, it gives you a couple of important options here. To display the equation on the chart. So we'll turn that on, and then display R squared value on the chart. Okay? So what it's done is it's taken a look at the data that's in here, and it put in this trend line that best fits the data according to a linear pattern. And it did linear regression to do that. And what it's trying to minimize is the distance from the point to the line. And it's trying to do the best overall cumulative distance being minimized for all of the data points. And so you can see that up here, the data point is pretty far above the line. And the same over here, this data point's above the line. And so we've got a goodness of fit. The R squared value tells you basically how well the data is fitting the trend that we came up with. And one way of thinking about it is that it's describing 76% of the data variance. So, I mean, that's not exactly it from a technical standpoint, but the higher the R squared value, the better the data is fitting the trend line. And the best you can have is 1.0. So let's try other types. If we right-click on that trend line again, it brings up the trend line options. And it assumed, just to begin with, that it was linear. Well, let's try clicking on logarithmic and see if logarithmic gives a better R squared value. It's going to give us a different equation, but will the R squared value improve? Won't work. And the reason why is because we're including 0. Our data set starts with 0. Now, if we weren't graphing the zeros, if we just were graphing the data points not including 0, it'll then do a logarithmic. And it looks like the R squared value is a little bit better. But remember, we had to throw out one of the data points that we know is true for the logarithmic. So let's not go with the logarithmic data. Let's take that trend line and just delete it and change the graph back so that it is including all of the data, including the 0 there. And so the nice thing is when you click on a graph over here, in my case it's doing it purple and blue, it shows me what is the data that's being graphed. And so I could make adjustments if I wanted to. I can click down and just graph a portion of the data, or I can have it change so that it's all of the data, including the 0. So let's right-click on one of the data points again and add a trend line. One of the options, it assumes linear to begin with. I'm going to turn on the R squared and the equation. One of the interesting things we can do, one of the options that it gives us for the trend line, is you can force it to go through the intercept. So if I turn on this, it's going to force it so that the line has to go through that 0. Now the R value is lower than it was before, but it makes the equation simpler. If we know that there's no way that you can have a negative flow rate, right? That's true. There's no such thing as a negative flow rate. That you may have a situation where you want to force the intercept to a certain value. All right, so let's try also a polynomial as another option. So here I'm going to do a polynomial equation. And now my R squared value is quite a bit higher with a second order polynomial. Now my R squared is 0.96. And you can change it to a now look at the equation right now. This is a second order polynomial. If I make it a third order polynomial, my R squared value goes from 0.96 to 0.99. So now it seems to be doing a really good job describing the data, but the equation became more complicated. The relationship between X and Y. So let's do something. Let's move this graph to the side here. And this is the actual flow that was like measured from observations out in the field. And then this one we're going to call predicted flow. And the predicted flow is going to be based on this equation that Excel just gave me, this y equals x equation. Now y is the flow rate and x is the height. So what it's doing is it's trying to predict what the flow rate will be for a certain height. And so here I'm going to type in the equation equals 0.5378 times x squared. X is my height value. Oh, it's cubed. X cubed minus 2.6488 times x squared plus 4.9331 times x minus 0.0955 and enter. And I can drag that formula down and it is going to predict the depth based on the equation that it curve fit. And so here we know the actual data and then here is the predicted. So for example here the data point was a little bit higher than the actual line, and that's what we're seeing right here in this instance. It's that 2.92 feet. The actual flow was a little bit higher, the prediction line. But we could put in any height and it would give us a predicted depth. So like what if I wanted to find out what would be the predicted flow rate for a depth of 4.5 feet? I can do something here. I can click on the row 9, right click and insert. I want to put in a new line here. I want to have 4.5 as my height, and it calculates what the predicted flow rate would be for any height I care to put in. 1 foot, 2 feet, 4.5, and it's calculating based on the formula that it got from this curve fitting. Okay, I wanted to point something out. In some cases, if you had previously turned on the forced intercept to 0, your equation may look different than what mine got. So I turned it back off that we had this forced intercept to 0, and then that's why this equation has 1, 2, 3, 4 terms. Once you feel like you've got the chart that you need and you're able to use the equation to come up with the predicted flow, be sure to go into this 2.9 and save the Excel file that you were working on for today. Just as a reminder, the assignment that I gave you today is due on the 21st, which is a Tuesday, not a Thursday. It's due on the 21st, and this one relies on that starting file that you get from the homework assignments folder. And so actually you'd be able to solve problem 1 and problem 2. You could probably sit down and knock that out today if you wanted to. Problem 3 is going to be based on an in-class exercise that we'll do during future classes. And so you can't start on problem 3 quite yet, but you could do the first 2/3 of the assignment already if you wanted to. All right, that's all I have for you today. Be sure to upload that Excel file, and feel free to stick around if you want me to take a look at your spreadsheet. I'm happy to stay and do that.
Well, we're uploading.